In this video, we will continue where we left off last time. In the previous videos, we had worked our way through the first part of this portfolio selection case, and we had made a workflow that looked something like this, and we had selected the 250 stocks using the algorithm that our Word document describes that we should use. So we've been working through all this, and we've gotten through step 4. We picked the stocks in step 3, and then in step 4 we looked to see what industries our stocks were in. And in this video we want to do step 5. We want to assess the performance of our portfolio relative to the market from which we picked our stocks. How did our portfolio do in 2013? How did that market that we picked our portfolio from do in 2013? So it's sort of try to make an apples to apples comparison between holding these 250 stocks that the algorithm says to hold versus just holding the market that you pick the stocks from, the whole market. So before we do that, we need to create 2 output files, one for the 250 stocks and the other one for that market, so that we can see how those 2 groups performed in 2013. And so if we go back to our workflow where we're selecting these 250 using the algorithm, I believe right after this step, right in here, excuse me, we have there are the 250 stocks company ID numbers. So we want to output that to a file, and we'll just put it on our desktop here, and we'll call it portfolio IDs. And then backing up back to here, these were all 2,627 stocks that we if you recall, we started at the very beginning with a bunch of stocks, and then we imposed these trimming criteria right up here. We cleaned the data, and then we imposed these 3 criteria. And after doing that, we're left with this 2,627 firm quote-unquote market, and that's the market that we ran the algorithm on. So that's the market that we want to compare our 250 stock portfolio's performance to in 2013. We want to compare this market's performance in 2013 to the. So if we would have held all of these firms so we pick them at the beginning of 2013. If we would have held these firms, all of them, the whole market at the beginning of 2013, how would we have done? Versus holding only 250 of these firms. So we have to know, well, what are these firms, right? What are the company IDs of these firms? What are the company IDs of the 250 firms? So that's what we're saving right now. So we output the 250 firms company IDs to a file right here. I just did that. And then the whole market's IDs, we got to go back here and output these to a file. The only thing is we have to attach another select tool first, because we don't want to output, we just want to output column 1 here, not columns 1 and 2. But let's see, we might not have to have a select tool. We could just, with our output, excuse me, with our output data tool, we might be able to just grab the first column. Is there a way to do that here? I thought there was. There's got to be a way. Maybe not. So let's put a select tool in here, and we'll undo that. And then we will output this to a separate file, .csv file, which we'll call market portfolio IDs. And then we'll run this workflow here. And then we'll just go verify that these two files were created on our desktop. So we go in here to our, where did I save them? I saved them right here. Yeah, portfolio IDs and market portfolio IDs. So if we click on this one, open it up, it should just be the 250 company IDs. It's called field name here because of the various tools we've been using have changed it, but and then there are the market portfolio IDs, the 2,627 firms. Excuse me. I hate when I'm congested when I'm trying to do a video, but I'm not going to redo the video just because of that. All right, so the next, so what we want to do basically in this video is we want to assess how these two portfolios did in 2013. So let's start a new workflow. Let's save this workflow here. So we're done with the selection workflow. That's the complete portfolio selection workflow. And now let's start a new workflow. And what we're going to do is we're going to bring in, have an input data tool here. We're going to bring in our portfolio IDs for the 250. And then we're going to bring in the market data, the whole market data for 2013, whole US stock market data here. And then we're going to join these two data sets. So this file down here has, if we run this, let's just run. And let's look at some of the data in this one. This file has all the companies, the date, just like the other file did, the 4-digit industry, the ticker, and the monthly return. It doesn't have the price or the cumulative adjustment factor. But so for any company that was publicly traded in the United States on a United States stock market in 2013, as long as it was publicly traded in any of the 12 months, the company will show up in here and its monthly return will show. So there's lots of companies in here that don't have of the full 12 months because they weren't publicly traded for in each of the 12 months in 2013. Maybe they delisted. Other reasons they might have a null value for a given month could be the database, the CRISP, the one who collects this data and assembles it, might not have the required information to calculate it. It's not that they delisted. It's not that they're not publicly traded. It's just they don't have the information to calculate the monthly return. So that could be another reason. But so what we want to do is find, if we want to assess how these companies that we chose these 250 from historical data as of the beginning of 2013. We look back in the past using 2010 through 2012 data. We chose these 250. And if we want to see how these companies did in 2013, then we're going to have to go and find the returns for these companies in 2013. So we need to join these two together. So we're going to join. The variable that we're going to join on, the only variable common between these two data sets is the company ID variable. So in this data set, it's called company ID. And in this data set, I think it's called field name. But that's fine. So in the left data set, the variable is field name. In the right data set, the variable is company ID. And we're going to join these together. And all we really want to keep is the company ID and the monthly return. Excuse me. And I'm actually going to drag this down a little bit. I'm going to give myself more room up here to do stuff. So in this workflow, the first thing we're going to do is we're going to assess how our 250 stock portfolio did. So we're going to follow step 5 in the Word document. We're going to do all these calculations for just the 250 firms. And then basically, we're going to repeat all of the exact same thing for the 2,627 firm market. So I'm going to do this workflow. It's going to go all the way over here. And then whenever I go to, and that'll, at the end of this, it's going to tell me how these firms did. Their returns and their standard deviation of returns, as you look, if you looked in the Word document. And then I'm just going to copy and paste all these tools down here again. And I guess from here over, from right here over, or from right here over, we're going to attach, down here, we're going to attach an input data tool with the market IDs, right, for the whole 2,627, and then we're going to join that to this data set and basically do the exact same thing. So we'll do that at the very end. That's just copying and pasting and then comparing the performance. But for our firms, we need to, for these 250, we need to do these steps here. So the first thing we need to do is we need to attach a select tool here. Excuse me. So if we look at the inner join, so you would think, okay, there's 250 firms here, and if each of these firms has all 12 months of monthly returns in 2013, then we should have, what, 250 times 12, we should have 3,000 rows in the inner join, right? Because for each of these firms, it should have found 12 monthly returns. But we don't have 3,000 rows, we have 2,932 rows. So that means for some of these companies, there aren't 12 months of data. And if there's not 12 months of data, what we're going to assume, if you look in the Word document, we will assume that if a firm does not have all 12 months of returns in 2013, they delisted. Now that's a conservative assumption. Assuming that and then calculating the performance of our portfolio will downwardly bias our performance if we're wrong in our assumption. In other words, if a company didn't delist, just because it doesn't have all 12 months, that doesn't mean it delisted. If that's true, then we're not going to put a return of negative 100% for that company. It's going to be a higher return than that. It's going to be based on the months that we do have for that company, and that's going to make our portfolio performance look better. But whenever you're doing any sort of research like this, you want to always make, if you're going to make simplifying assumptions, you want to make sure that they're not upwardly biasing your results. They only could downwardly bias your results. And then if you still find results despite that, then you know you would have found results if you hadn't made that simplifying assumption, right? Because the simplifying assumption downwardly biased your results. So you always want to be conservative. So that's what we're going to do here. So you should assign a rate of return of -1 in the month they delisted and a 0 rate of return for every month after that. So that's going to require a little bit of coding. So first thing we definitely want to do is we want to take this monthly return variable and change the data type to double. We're going to do all sorts of arithmetic stuff, arithmetic calculations with this variable, and we can't do that on V-string data types. You guys know that. So we'll run that. All right. Now what we can do is we can go ahead and add 1 to all of these monthly returns, because when it comes to finding the annual return for a given stock, if you look at formula 2 here, when it comes to finding the annual return for a given stock, which is what we want to find, we ultimately want to find the annual return, the 2013 return for the whole portfolio of 250. But to do that, we have to first find the 2013 return for each of the stocks, for each of the 250. And so this is the formula to calculate for a given stock I. I represents any one of the stocks. I goes from 1 to 250. For a given stock I, this formula will give the annual return for that stock. And so what you do is you just add 1 to each of that stock's monthly returns. So R sub I1 is the return for stock I in month 1. R sub I2 is the return for stock I in month 2, is what it says right up here. And so forth. You just add 1 to each of those, and then you multiply all those together, those 12 numbers together, and subtract 1, and that gives the return of stock I for the year and that includes compounding, right? You don't just average the 12 monthly returns to get the annual return. That will not take into account compounding. And I could go through, I could show you with a Microsoft Excel example that this formula actually is the annual return. You would get the same thing, the same annual return, if you actually had the starting price and the ending price of the stock and did the normal way of calculating return. You know, ending price minus beginning price divided by beginning price. You're going to get the same number as compounding the monthly returns this way. In other words, you can get the annual return on a stock without having its prices. If you have the monthly returns, you can still compute the annual return without having the beginning or the ending price using this formula. It works. So you can just take my word for it. Mathematically, this is correct. So we may as well just add 1 to each of these monthly returns because we're going to have to do that anyway for all the stocks for all the months. So let's bring in a formula tool, and we will actually change the monthly return column itself. We won't create a new column. We're going to change the monthly return column, and we're going to say, actually, you know what? No, we're going to create a new column. We're going to create a new column. It's dangerous sometimes to change a column because then if you mess up, you don't have the original column. But I guess in Alteryx you always have the original. You could just go back a step to a tool. That's the good thing about Alteryx. But so we're going to create a new column. We'll call it return plus 1, and it'll just be equal to this monthly return column plus 1. And we definitely want to make it double. So run that. All right. So let's look. So we should have just added 1 to all these numbers. But if we go down far enough, we're going to quickly find a firm. Take firm whose company ID is 11839. And it looks like they're in the database for the first 11 months. And then in month 12, they didn't have a monthly return. So we're going to assume that they delisted in month 12. So according to the Word document, that's what the Word document says. It says to assume the company does not have all 12 months of returns, they delisted. You should assign a rate of return of -1 in the month they delisted and a 0 rate of return for every month after that. So we're going to assign that -1 later. But right now, what we want to do is we want to compute equation 2. We're going to compute just this part of equation 2, just the product, not the -1 yet. We're going to write a formula. We're going to use a tool in Alteryx and write the multi-row formula tool, and we're going to compute the running product. So what that's going to do is it's going to multiply these numbers for each firm by, it's going to get the product essentially, because that's what we're going to need in the end for each firm. And it is true that when we get down to a firm that does not have all 12 months of returns, like this is the first firm that we see that doesn't, firm 11839. It has 11 months of returns, but the 12th month is missing, so we're just going to say the firm delisted in the 12th month. Calculating a running product, then when it calculates the running product, it's just going to calculate the product of these 11 numbers, and it'll treat the null as, it won't treat it as 0, because then the running product would be 0. But it's going to be, it's just not going to include it in the calculation. And so the final, and so that'll create a null value here in our new running product variable for that 12th month, which is fine. We're at the end, we're going to add the -1 return for that firm. Because if a firm delists and you can't sell the stock before it delists, you earn a -100% return, right? Because you spent X dollars to buy the stock, and you got $0 from selling the stock. So 0 minus X is -X. Divided by X, your original investment is -1, -100%. So that's why we're putting a -1. And then So let's do this multi-row formula tool. And I think I've shown you this in the previous video, but we're going to create a new variable. We're going to call it product. And we're going to group by company ID. Values for rows that don't exist, we want to make those null, not 0, because then with the running product, everything's going to be multiplied by 0, and then everything's just going to be 0. And then we're going to write an if-then statement, but we're going to write it in a different way. There's two ways to write an if-then statement. So you can write it if some condition, then do this, else do this, and then end if. This is one syntax. But another syntax of if-then is you can do if. So if, or if. And the syntax, it's like a function. So you parentheses, and then this function has 3 arguments. So this is the condition first, whatever there, then a comma. And then if that condition is going to hold true, what do you want to happen? Goes here. And if the condition is going to be false, then what do you want that to happen? Goes here in the third argument. So what we're going to say is if the previous row of our product variable is null, that's the condition we're checking for its truth or not, then let the current row of our product variable equal 1. Else, if that condition right here is not true, then what do we want the current row of our product variable to be? We want it to just be equal to the previous row of our product variable. And then we're going to multiply the output of this if statement by our current row of return plus 1 variable. Make sure we're grouping by company ID. Yes. So let's run, and you'll see what happens here. No, we don't want that. What did I do? Oh, I see what I did. So right there, I gave the product always as 1, 1, 1, 1, 1. But the problem is the product variable doesn't need to be an integer. Then it's just going to round to the nearest integer. We want it to be actually have a decimal representation. So make it a double, and then it'll work fine. So row 1 of product variable. So if row 0 of product variable, that's what this is saying, the previous row of the product variable, if it's null, which it is, because row 0 of the product variable doesn't exist, and values for rows that don't exist are given a value of null. So row 0 of the product variable is null. So row 1 of the product variable should equal 1 times row 1 of the return plus 1 variable. So 1 times that is that. Row 2 of the product variable, what should that equal? Well, if row 1 of the product variable is null, it's not null. So then we move to this part. So that means row 2 of the product variable should equal row 1 of the product variable, right here, multiply by the row 2 of the return plus 1 variable. So multiply by this. So these two numbers multiplied together is this. And you'll see that means then it will just multiply. So this number essentially is these two numbers multiplied together. This number is these 3 numbers multiplied together. This number is these 4 numbers multiplied together. It's the running product. And that means the last row of this firm appears. So this number is the product of the 12 monthly returns for that firm. This last. And that's fine. Now, we just need to attach a summarize tool and group by company ID and find the last value of this product variable. We'll run this. And we'll look at our output. And so for each firm, then, it gives the last value of the product variable. All we have to do is subtract 1 from this last product, and that's the annual return for each firm. We will have computed R sub IA for each I. Notice that for some of the firms, the last product is null, and for those firms, the annual return is going to be equal to -1. We're just going to set, because for these firms, if this last product is null, it means that that firm did not have all 12 months of returns. It delisted in one of the months. In the month that it delisted, it had a null value for the return and had a null value for every other month after that, after it delisted. That's what it means. We could verify that if we went back and looked at the data carefully, but you can trust me, that's what it means. And so if the firm delisted, and we're assuming you didn't sell it before it delisted, then your return for in the month that it delisted is -1. Your return for the whole year is -1. You lost all your money. You couldn't sell the firm before it delisted. That's what we're going to assume. It's a conservative assumption. It's going to bias the performance of our whole portfolio downward. So what we need to do now is subtract 1 from each of these returns. Of course, here when we subtract 1, it's still going to be null, so that's fine. So let's do that. Let's create a formula. Let's have a formula tool here, and we will create a new variable, and we're going to call this the annualized return for each stock. And it's just going to be equal to our last product -1. And we're going to make it double. So there we go. So we have the 2013 return for each stock right here in this column, for each stock in our portfolio. And then what we want to do is, let me go back and make sure that I'm and then what we want to do is we want to attach a summarize tool or a formula tool, and we want to change the annualized return column itself and say if the annualized return column is null, so if actually, you know what? I could have done this. I don't need to do this with another. I could do this right here. I could just add, I can change the annualized return because it'll do, this formula will do this first and then it'll do this. So if the annualized return is null, so if is null function annualized return, then then set -1, else just let it equal whatever is in the annualized return, end if. And then run. Then let's go look here. So for the annualized return for this stock was set equal to -1. For this stock, it's set equal to -1, and so forth. And now we have a number for every firm, then that's their annual return, and we just have to take the mean of these 250 annual returns will give us the portfolio's return, and that is equation 3. So once we have the 250 annual returns, we can simply compute their mean to derive the annualized portfolio return as follows. This computation assumes we invest an equal share of income into each stock. And yes, it does assume equal weighting. So this is the formula for the mean, right? If we have the 250 stock returns, then we just add them up. That's what the summation here is. And then divide that sum by 250. And that is implicitly assuming that we're putting, given an amount that we invest X into this portfolio, 1 over 250 of X was invested in stock 1, 1 over 250 of X was invested in stock 2, 1 over 250 of X was invested in stock 3. Assuming that we equally weighted the stocks, then this is the portfolio return. It's just the mean of the individual stocks returns. Now, if you don't equally weight the stocks, then simply calculating the mean or the equally weighted average of the individual stock returns does not give you the portfolio return if you don't equally weight the stocks. But we're going to assume that you equally weighted the stocks. So all we have to do is calculate the mean. So we can just go use the summarize tool here. There's different ways we could do it. We can just use the summarize tool, and we can just choose annualized return and compute the mean. So how did our portfolio perform in 2013? 31.61% return. In other words, if you would have invested $10,000 into these 250 stocks at the beginning of 2013, then at the end of 2013, when you sold all of your stocks and the cash was put in your account from the sale of your stocks, how much cash would be in your account? Well, it'd be $10,000 times 1.316131, or $13,161. You would have made a 31.61% return, or a $3,161 return on a $10,000 initial investment. That's what it means. So we did pretty well. All right. We've gotten through, we've done equation 2 and equation 3. Now we need to compute the risk, or we need to estimate the risk that we took in investing in these 250 stocks. And there's a measure that academics use to proxy for or to estimate risk, and it's the standard deviation. So we want to calculate the standard deviation of the annualized portfolio return. It's a measure of, on average, how much did our portfolio return move during the year. So to calculate it, we first need to compute, it says right here, the mean of all 250 firm returns for each month. So month 1, all 250 firms, compute the mean of their returns. And that will be the return for the portfolio in month 1. Then month 2, compute the mean of the 250 firm monthly returns. That mean will be the portfolio return in month 2, and so forth. So we'll have these 12 portfolio return numbers, one for each month. So that's the first step we need to do. Again, if a firm in a given month has a missing return, or it's null, then we're going to assume that the firm delisted in that month, and we're going to put a return of -1 there. And then every month after that, where it's null, we're going to put a return of 0. And that's what it says up here. All right, this is the kind of the trickier part. So let's bring a formula tool back down here. Whoops, I didn't mean to attach that there. Delete that right here. And With this formula tool, so if we go back here and we look, this is just every firm and their monthly returns for the whole year. And so anywhere we see a monthly return of null, I'm just going to change that to -1. And I do realize that for a given firm, there might be 5 different months where there's null. And the first one we want to be -1, but the ones after that we want to be zeros, according to the Word document. But I'm going to make them all -1, and then we'll change it back later. So what'll happen is for a given firm, if it has a monthly return of null in a certain month, then it won't have any monthly returns in any months after that month. It won't show up anymore. That's what happens in this data. See, 11,839, it happened to have a null in the 12th month. So of course it's not going to show up anymore. There's no more than 12 months. So that's not a good example. Let's find a firm which had a monthly return of null, but it wasn't in the 12th month. It was like in month 5 or something. Let's have a look. Here's a firm right here that they have a monthly return. This is the first month they show up, and it's null. And then they don't show up anywhere else. So, in other words, for a given firm on this side, there will be no more than one row where their monthly return is null. There'll be only one row where it's null, or there won't be any. And so we're going to set the row where it's null for each firm equal to -1. That's what we're going to do. And I'm actually going to change the monthly return column itself, which can be dangerous, but I'm going to do it. So if is null, monthly return, then set equal -1, else just, if it's not null, just let it be what it is. Oh, I should probably attach this to this, because this is a V string and we can't do this. We want to make, and here I changed the monthly return to a double. So yeah, let's do it this way. So let's run. And if we look here at our data, it should show like that firm 11,839 or whatever, the month in which it was null, it should have put, see right here, that was a null value before, now it's a -1 and so forth. All right. All right. Now, if we're going to calculate for each month the mean of all 250 firms' returns, we need to get our data in a different, what's the word? A different alignment, or a different layout. What I want is for each firm to be a row. And then, so for firm 10180, its month 1 return will be in column 2. Its month 2 return will be in column 3. In column 1 will be its firm ID. Its month 3 return will be in column 4, all the way out to its month 12 return will be in column 13. And then the second row will be firm 2. Its month 1 return will be in column 2. Its month 2 return will be in column 3, and so forth. I want to just basically almost transpose this. But we're going to learn a new tool here to do this. And it's called the Make Columns tool. So in your search box, you want to type Make Columns. Now, Make Columns, you'll notice, has the same color as Summarize, as Crosstab, as Running Total, as Transpose. So you would think, oh, it's in the same category as these tools. These tools are in the Transform category, so when we go to the Transform category, you don't see Make Columns there. Make Columns is a tool, it's one of the examples in Alteryx where it is in this category, but you can't see it in this category when you select this category. The only way you can find it is you have to search for it. There are other examples of tools like that in Alteryx, but Make Columns is the only one example that we're going to learn in this course. This is the only tool that's not actually in any of these categories. You can only find it by searching for it. I mean, it's part of the Transform category, it just doesn't show up in the default configuration of Alteryx. Why? I'm not sure, to be honest. All right, so Make Columns tool. All we want to do is change the number of columns to 12. We want to arrange them horizontally, and we want to group by company ID. And this is what the output will look like. So it's exactly what we wanted. For company ID 10180, there's its month 1 return, it's in column 2. There's its month 2 return, it's in column 3. There's its month 3 return, month 4 return, and so forth. Let's jump down to this company 11839. You'll notice that it's month, oh, okay. It's month 11. So in month 11 is when the null value appeared. Let me go back. I was saying month 12 it appeared. Let's go all the way back. And I wasn't really counting up correctly. So if we go to 11839, so that's 10 numbers right there, if you count those. So in month 11, it had a null, and then it did not have a month 12 return. Like I told you, if a firm has a null in a given month, it doesn't show up for any other months after that. However, when we do the make columns, so that firm only has 11 data points. It has the 10 months plus the one that was null, which we set equal to -1, right? So it has the 10 numbers, one for each of the first 10 months. Then it has the -1 that was null, but we changed it to -1. And then you probably wonder, well, why does it have a null value month 12 when in the original data set it didn't even have a number for month 12? There's only 11 numbers for that firm. Well, that's because with the make columns tool, if a firm above it has 12 numbers and the firm below it only has 11, well, it's got to put something there if it's going to, there's a column here. This is the column for the monthly return in month 12, and I know some firms don't have a number there, but it's got to have a column, so it just automatically puts null there. So what we want to do is we want to put, for any firm which has a -1 in a given month, like this one, we had assigned that, right? This is another example of one that delisted at the end of month 10. At the end of October, it delisted, so in month November, it had a null. We changed that to a -1. In month December, it automatically put null here because when we do the make columns tool thing. So we want to change this to a 0, this to a 0. Let's look at another example. Here's a firm on row 49. It's that 75773 firm. It had a null value in the first month. It delisted right away. So this firm, when we picked it as of January 1st, 2013, it was trading. Or as of December 31st, 2012, it was trading. Otherwise, it wouldn't have ended up in the algorithm wouldn't have picked it up. It was trading publicly. And then immediately it delisted. It didn't last all the way through January of 2013. So we earn a 100% negative 100% return on that firm in January, and then we're going to put a 0 for all these other months. That's what we want to do. Let's see, are there other examples? Yeah, here's a firm right here that in January it had a return. In February the return was 0. In March there's a return. And then it delisted in April. So that's what previously was a null value. And then we changed it to a -1. And then all the other months after that we want the return to be 0. I mean, once we've already lost the money on the company, then the return to the other month in that company is 0, right? We neither lost or gained anything. We want to change these all to 0. So to be consistent with what the Word document says to do right here. And it makes sense. You should assign a rate of return of -1 in the month they delisted and a 0 rate of return for every month after that. So let's do a formula. And now this formula is going to be kind of long, or there's going to be a lot of stuff here. Because what we have to do, if we go back to our output here, is for each variable, for each field, for each column, we have to look, and if it's null, we want to set it equal to 0. So for each column, in each column, we want to look at every row, and if the row is null, we want to set it equal to 0. So we want that number, that'll be a 0. This will be set equal to 0. So we have to do that for each column, right? And when you use the formula tool, you do it based on columns. Well, there's 12 columns we have to analyze, right? So the first one is the column 1 monthly return. So if is null of column 1 monthly return, whoops, then set equals 0, else just let it equal what it was, what it ended up being, end if. But then we got to do the same thing for column 2. We got to write this formula for all 12 columns. So I'm just going to copy and paste. You got to change the 1 to 2 here. You know, and just repeat this for all the other 12 columns. For all the 12 columns, you got to do this. Oops, that wasn't right. So this will take just a second here. I'm a third of the way done. Just be careful that you don't mess anything up here. All right, I'm halfway done. All right. We're almost done with this step. Now there may be a faster way to do this, but this is the way that I figured out how to code it so that we do what the Word document says. This is the way that I'm doing it. All right, let's run this. And then let's just go verify. Take that 11,839 firm. That's a -1, and that was null. We changed to 0. Same thing down here at this firm. That was -1 already. That was a null. That changed to 0. Here's this firm. That firm 75773 that delisted in January. We changed that to a -1. These were all nulls, but we changed those are now changed to 0 because of our formula, because it looks in each column, and if it sees a null value, it just changes it to 0. All right. Now this is great. Now what we can do is calculate the mean of each column, right? Because now each column has a number, has a monthly return in each column. So this is the month 1 return for this firm, this firm, this firm, this. So for each firm, there's a number, and it's not null. It's either a legitimate number, or it's -1 because it delisted, or it's 0. So yeah. So when we calculate the mean, it's actually going to be meaningful. No pun intended. Right? Because if you calculate a mean of, this column, but there's 5 nulls in that column, it doesn't include the nulls in the calculation of the mean. It just calculates, if the column has 250 rows and 5 of them are null, it just calculates the mean of the 245 rows that aren't null. But we don't want that. We want the mean of all the rows. We don't want anything to be null, right? So now we can do, so once we have the 250 annual returns, now we have, or I'm sorry, we can simply compute their mean. No, that's not it. We did that already. We're down here. We need to compute the mean of all 250 firm returns for each month. This monthly mean is the portfolio's return for that month. Again, assuming equal weighting. So that means we can just attach a summarize tool, and we can group by, or we can just calculate the mean of all these. So I just select all of them and then calculate mean. Bam. There's the month 1 mean, there's the month 2 mean. So this is the portfolio's return in month 1, portfolio's return in month 2, portfolio's return in month 3, and so forth. Again, the red just means it's been rounded to 6 decimal places. That's all it means. It doesn't mean there's an error. All right. Now, once we have those 12 numbers, now it says next, let S sub m be the standard deviation of those 12 portfolio monthly returns. And let M sub m be the mean of those 12 portfolio monthly returns. So once we calculate S sub m and M sub m, then we can calculate finally equation 4, the standard deviation of the annualized portfolio return. It's a measure of risk again. We already calculated the annualized portfolio return in equation 3. What about the standard deviation of the annualized portfolio return? That's equation 4. Well, we need Sm and M sub m. As you can see first, they go in this equation. S sub m is the standard deviation of those 12 monthly portfolio return numbers. And M sub m is the mean of those 12 monthly portfolio return numbers. In other words, we need to calculate the standard deviation of these 12 numbers and the mean of these 12 numbers. The former will be S sub m, and the latter will be M sub m. And then we can use equation 4 to find what we want. See, equation 4 just has 2 inputs, S sub m and M sub m. All right. Let's just transpose first. So I just attached the transpose tool. That'll put this from a row to a column, like this. And now we can calculate standard deviation of this column and mean of this column with the summarize tool. Because the summarize tool works on the columns, not on the rows. That's why we just did a transpose. So now all we have to do is take value, and there's 2 things we want. We want the mean of it, and we want the standard deviation of it. So there is M sub m, and there is S sub m. This is the standard deviation of the 12 monthly portfolio returns. This is the mean of the 12 monthly portfolio returns. All right, now let's use a formula tool. And now we have to write this equation in the formula tool and pay particular attention to order of operations. So everything is under the square root sign. So in our formula, so let's create a new column. We're going to call it standard deviation of annualized portfolio return, right? Because that's what this is, standard deviation of the annualized portfolio return. And everything's under the square root sign, so it's going to be equal to the square root. There's a function in Alteryx called squirt, and everything that goes inside these parentheses is it's going to take the square root of this. All right, what goes inside the square root? Let's take it piece by piece. So let's take this piece first that I've highlighted on the screen. So this is S sub m squared plus 1 plus M sub m squared. So something squared plus something squared. And then all of that raised to the power of 12. All right. So we want to take S sub m squared. Now, you might think, oh, there's S sub m. We just go like this to square it. No, that's not how you do it in Alteryx. Alteryx, there's a function called pow. You can see pow x comma e. It raises x to the power of e. So we want to take pow S sub m raised to the power of 2, right? So this that's highlighted right here is s sub m squared. So it's s sub m squared plus parentheses, right? Because now we want to do 1 plus m sub m squared. So actually, let's plus pow of what? 1 plus m sub m squared. So we're raising 1 plus m sub m to the power of 2. So this is what right here is 1 plus m sub m squared. And then right over here is s sub m squared. And the sum of those two, we want to raise the sum of those two to the power of 12. So we want to do pow of those two things added up, raised to the power of 12. Close parentheses. So that, what you see right there in the formula, is everything. It would be the square root of this first part. But now, also underneath the square root, we want to subtract 1 plus m sub m to the power of 24. So stay under the square root, so don't go outside this parentheses. This parentheses is the end of the square root. We want to say minus, what is it? Minus, and then 1 plus m sub m raised to the power of 24. So minus pow of 1 plus m sub m raised to the power of 24. Close parentheses. Finally, we have it, and we can set this to a double. Boom. So there is our standard deviation of annualized portfolio return. And our annualized portfolio return was there, that number. So we had a 32% annualized portfolio return and an 11% standard deviation of annualized portfolio return. Now, those numbers by themselves don't mean much, but I can tell you that's a pretty good return and a decently low standard deviation. You want the standard deviation obviously to be the closer to 0, the better. So taken by themselves, they don't mean a lot, but whenever you compare them to another portfolio's annualized portfolio return and standard deviation of annualized portfolio return, then the numbers kind of make more sense in regards when you do comparison. What I want to do though now is get these two numbers together, not in different places. So to do that, all we have to do is union. First, do a union. So we're going to put this data set right here underneath this data set. This data set only has 1 row and 1 column, and that's going to be stacked on top of a data set that has 1 row and 3 columns. So you'll see what happens. Now let's run. So now the values are together in the same data set. Here's the average, here's the annualized portfolio return, and here is the standard deviation of annualized portfolio return. But how do we just get these two numbers by themselves? It looks like we can just do a summarize tool, and we can take the sum of this column, or we can just take the first value of this column, that'll be that number, and then for this column, we take the last value of that column, and it'll be that number, right? And that should do the trick. And now the numbers are by themselves. There's the performance of the portfolio in terms of return, and there's the measure of risk. This is like the reward, and this is the risk that we had to take to get that reward. And now what we want to do is compute, finally, the Sharpe ratio, which is just the reward divided by the risk, equation 5. And the Sharpe ratio is what we can use to compare two different portfolios of different sizes. You know, this portfolio, there's 250 firms, but the other portfolio that we're going to compare it to is the whole market, which has 2,627 firms. And once we get these two numbers for the other portfolio, for the market portfolio, it's really hard to compare those numbers to these numbers because the two portfolios are different sizes. But if we take the ratio of the return to the risk, then we can compare that ratio. All right. So let's finally compute the Sharpe ratio, and we will be done with the 250 firm portfolio. So we're going to add a new column. We'll call it Sharpe ratio. It's named after an academic from the University of Chicago in the 1950s or 60s named William Sharpe. He came up with this measure. He wrote a paper and said, hey, you can't compare portfolios, but if you use this ratio, then you can all of a sudden you can start doing apples to apples comparison. So the Sharpe ratio would just be the ratio of this thing divided by. The name has now changed a bunch since we've done a lot of tools, but it's the ratio of the annualized portfolio return, this number, to the standard deviation of annualized portfolio return. So this essentially means for every 1% of risk we're willing to accept, that gets us 2.885% of return. That's what the 2.85 means. Because both numerator right here and denominator are measured in percentage terms. And so this thing is just, it's unitless, right? Percent over percent. The units cancel, and it's just 2.85. It just means for every 1 unit of the denominator, we get 2.85 units of the numerator. And they're both measured in percentages, so every 1 unit of risk we're willing to accept, for every 1% of risk we're willing to accept, we get 2.85% of return. Investing in this 250 stock portfolio that the algorithm says to invest in. Now, what's the performance of the whole market? If we instead of doing the algorithm on that 2,627 firm market and only investing in 250 of those stocks, instead of doing that, what if we just bought all those stocks? How would we have done? At first thought, you might think, well, if we got the whole market, then our standard deviation should be lower volatility, lower risk, because we diversify more. Instead of only owning 250 stocks, we own 2,627. Surely that's diversified more, so our risk should be lower. So our standard deviation should be lower. That's what you would at first assume. But in fact, we're going to find out that's not true. Yes, you have more companies, but those companies are more correlated with each other because this algorithm is all about correlation. And if you choose a subset of those companies who have very low correlation, like we did, these 250, it turns out the standard deviation of those 250 is going to be lower than the standard deviation of the whole thing from which those were chosen. So we're going to get less risk with these 250, more risk with the other market. We'll see that here in a second. And then as far as the returns go, well, the algorithm was agnostic with respect to returns. I never claimed anything about returns. But we'll see what happens on the return side. The algorithm is only designed to minimize risk. It's not designed to maximize return. All right, so how did the 2,627 firm market that we chose these 250 firms from do in 2013? Well, we need to do the same thing that we did. We need to bring in an input data tool. We need to bring in the company ID numbers for those 2,627 firm market companies. And we need to join these here and find the performance, because this right here file again is the monthly returns for any firm in 2013. And these firms, we just want to see how they did in 2013. So we need to join these two together. So basically, and then we need to do the exact same steps that we did for the 250. So basically, I can just copy and paste all of these tools. I'm holding down CTRL and left-clicking all these tools. So just copy that and then click over here on the open white space and paste. And then just drag and attach. Now make sure we attach this to the left side of the join. So make sure we attach this to the left side of the join. Or it doesn't really matter. We can attach it to the right and attach this to the left. But if we do that, then we have to change. So then in the left, the field is called company ID, and in the right, the field is called field name. There we go. And then run. Then a drum roll. Drum roll, please. And this should have done everything that we did up there for those firms. So, oh, it's null. Why is that null? Those should be 3 numbers that we can compare the other numbers to. So let's see, where do things go awry? Trying to find at which step did they go awry. Do we have them here? Is everything good up to this point? Oh yeah, I see what happens. So for this column we want the last number, and for this column we want the first number. That was the problem. And so down here we want to change this to last and this to first. And then in this we want to divide this by this. There. So now if we look, so there for the market, if we held all 2,627 firms in 2013, that would have been our return, 34%. That would have been our standard deviation. That would have been our Sharpe ratio. Notice the standard deviation is higher, and the Sharpe ratio, therefore, is lower. So for every 1% of risk we're willing to accept, we only get 2.45% of return investing in the 2,627 firms relative to investing in the 250 firms. And let's put these numbers together. So the numbers for the 250 and the numbers for the market together. So I guess this is the final step. We just union. Both of these data sets have 1 row and 2 columns. So the union will have 1 row and 2 columns. Or wait, why don't they? Let's see. Oh, it's because the names of the columns are different. It has to do with, you know what I should do? Let me undo these steps. Let me undo. 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 I'm going to undo everything I did. Hold on. Undo. 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 If I attach this, because I just copied and pasted, and notice on this side, these were attached to the left, and then this was attached to the right. And if I do it that way, and then run, everything should be just like it was up here, and I don't have to. Now look. Oh no, it's not. Why? It's because of this. Because of this. Why is... We're just into formatting at this point, so don't worry about this. Oh, I need to take the last and the first. So it's going to force me to do this. I could go back and trace why this isn't working out, like formatting wise, but so then this changes from last divided by first, then run. Get my numbers here for the market. Those are the numbers that we got, and then I want to put them together. So if I union, let's just do it this way. Let's try this union. The 3 numbers we want together are, these and then these. Oh, geez. I'm trying to put them all like where you can see, you know, the 250 firm portfolio, it's three numbers, and then the market portfolio, it's three numbers. But the reason why it's not doing well is because the names of the variables aren't the same in these two data sets. See up here, the names if the names of the variables are different, it's the same variable, it's just different name. So before we do the union, maybe if we change the name. Um, if we change the name to geez, if we go down here, what are the variables called in this data set? Last underscore average underscore annualized return. First underscore standard deviation of annualized return. Okay. We need to change the name this from last to first, and this from first to last, essentially. So then it'll line up. So let me make this bigger so you guys can see. So just change this last underscore. All right, make sure annualized portfolio return. Whoops. All this just to get the formatting thing to look right. And then this was gee whiz. What does this need to be called? I'm forgetting. First underscore average underscore annualized return. There. Now if we do a union, then it should, since the variables have the same names, columns have the same names, it should, there we go. So here's the performance of the 250. Here's the performance of the market from which those 250 were chosen. Return, standard deviation, and then Sharpe ratio. So this finally is what we wanted to produce. We wanted to produce these numbers so that we could compare and contrast the two portfolios. Notice that the market portfolio did do better from a return standpoint, but it also, to do better, it took on more risk. If you repeat all of these steps that we did in this case, and you repeat it for 2012, 2014, 2015, for all the years, how does this algorithm work compared to holding the market? And you average your results. What you're going to find is the average difference between returns is 0. So the portfolio performs just as well as the market in terms of return. The difference, though, in the standard deviations on average is statistically significant. The market is greater than the 250 firms. Statistically significantly different, greater than. So more risk. Same return, more risk. And the Sharpe ratio, you find the Sharpe ratios of the 250 firms is greater, statistically significantly greater than the market. If you, and that's what my research has done. So if you repeated all this, basically we've just done this for 1 year, 2013, but if you did it for every year from 1950 through 2017, which is what I did, and you average your results, you tend to find that you get the same return holding the 250 as you would have holding the market on average, same return, but to get that same return, you take on less risk, a lot less risk. These numbers tend to be strongly, significantly different from each other. And therefore, the performance of your portfolio is much, much better. So this concludes the video.